is George, and this is my Unix and Linux lab experiment number 3. That is about looping control statements in shell programming. That is about for loop and while loops and all the loops inside this. So the first one is to print a Fibonacci series. So we'll just see the code for that and then the output. So we'll go to the first Fibonacci. So what is here is like first we will show how many number of terms the user want to be generated, and then we will like take the input by read n, and then we have initialized three variables x, y, and I as 0, 1, and 2, and we'll just print echo, like we'll print on the screen Fibonacci series up to the number of terms, and we'll take the value as x, and we'll show the value of x and y because Fibonacci series starts with 0, 1. These two are compulsory, so we'll just print 0 and 1, and we'll check and we'll run a while loop, like while I is less than n, like while 2 is, if 2 is less than the number of inputs, we'll do like this, like expression 1 is I plus 1, so we'll take the value of I, and I plus 1 will make it 3, and from here we'll do as z will be x plus y, both the values of x and y, and we will echo z, and we'll take the value, and then we will put the value of x is equals to y and y is equals to z, because in Fibonacci the last two numbers are added to get the third one, like 0 and 1, and then we'll get 1, then 1 and 1 will get 2, and then 1 and 2 will get 3, and then 2 and 1 will get 3, and 2 and 3 will get 5, like that. We'll get substitute every time the last two values by y and z to get it. So we'll just see the code for that. So how many terms? I want 5 terms. So you can see 1, 0, 1, then again 1, and 1, 1, 2, and then 2, 1, 3. We get that many of terms. So the next one is shell script to find sum of the following series, like 1 square plus 3 square, the odd squares, and their sum. So let's go for that thing. It's here. It's in the directory. So yeah, the vi uh, dot sh. So this one is for the number of terms, like the square one. So we'll just show the number of terms to be generated, and then the limit of the series, and like we'll just print, like we'll take the input and we'll run a for loop, like for I is equals to 1 till I to the number of what the user has set, and we'll do as sum is equals to expression of sum plus I, the value of I will run from 1 to the number of terms, and we'll multiply it with I to get the square, and every time it will run, and it will be like 1 plus 1 into 1 plus 2, like 3 plus, like that. It will be squared every time, and it will be summed again, and then we'll just print the sum, we'll echo it. So you can see the code, you can see like as such, enter the limit of the series. If we get 3, we get 14. So that was it. We'll go to the fourth number to check whether a number is given is an Armstrong or not. So that one is like, so we'll check whether the number is Armstrong or not. So Armstrong is the number where we take each and every individual numbers, and we'll make the cube of that. So first we'll enter the limit of the series, and then enter a number, and we'll take the number and we'll read it, and if the number is like, we'll do I is equals to num, and we have initialized a num is equals to 0, and then we are making a while loop while $I is greater than 0. We'll do like digits, and in digit we'll take the modulus of that expression to get the last number. Like if it's 153, we will first take 3, and that we will cube it, like 3 into 3 into 3, and we'll put the value in cube, and then there's enum, like we'll make that enum is declared as 0, so we'll add that enum value to 0 plus 9, so the value of enum will become 9, and then again this will be done, and if it will be done like 153 is there, then it will be done with 5 and then 1, and its cube will be taken and then it will be added to 9 and all those things, the cube of every other number, and then we'll check if the number we are getting and the added number we are getting, if it's same or not, and if it's same we will show its Armstrong number, and if it's not we'll show it's not an Armstrong number. So just for that, search. So if it's 153 it's an Armstrong number, we'll show its Armstrong number, it will make the add of it, cube of it, and it will add for 454 it's not an Armstrong number, it will take the cube of it individually and it will add and it will not get the same number, so it's not an Armstrong number. We check the palindrome or not, show that also right now. And then there are, for palindrome also we will just do like the same thing, we'll just add it up, just show you the code for that. For palindrome also we are doing the same thing, like just like Armstrong we are adding, we are taking the input from the user and then we are just adding it up, we are making a for loop, we are like taking the last number by modulus and then we are dividing to get the remainder by 10, and then we are adding it up and we'll check the number we are reversed is equals to the number that was before that, the usual number, if it's correct or not, if it's matching or not, and if it's matching we'll just show it like there in case for a palindrome we'll give like set. So enter the number, if we give 131 so it will show it's a palindrome because reverse is also and we'll get 131, but if we give something else like this thing, give something else like 254 it's not a palindrome, so it will show it's not a palindrome. Then same happens with to print prime numbers between the given range, sorry. So to find this out we'll just like first we'll find the prime numbers between that range, we'll take two numbers, like here we'll first take a starting number and an ending number and we'll find the prime numbers between that, we'll just print it out. And what's a prime number? Like it's basically it can be divisible by 1 or by itself. So we'll put that in this thing condition, like we'll first run a loop from start to end and we'll increment that thing every time. And we have initialized I is equals to 1 and factor equals to 0. And then we have the file I is less than j and we'll do remainder is equals to expression of j modulus I. So we'll take the j value and we'll divided by the ith value and we'll take the modulus of that and we'll get the last value, and if the remainder is equals to 0 so then we'll put like expression is of that plus 1 and then we'll close that if situation if condition, and then we'll go to other one like I is equals to expr dollar I plus 1, and then we'll go to another one like if fact is less than 2 then we'll show that this, because if the factorial if the prime number is less than 2 it's of course 1, so I will show this. And so we'll go to the like set. So starting number is like 5 and the ending number is 9, so it will show two displays like 5 and 7 are the two prime numbers between that thing. uh, so that was it about the prime numbers and all. So yeah, so that was all it. Thank you for watching.